Okay, so today, logarithms, 3, 14, 18, pi, day, smiley face. Okay, there we go. All right. So, logarithms help us deal with exponents. Okay, so we'll just start right there, what we call exponential form. Okay, so I've got example 1. We want to go ahead and take something that's in exponential form, and we're going to change it into what we call log form. Okay, so we're going to take and we're going to do a transposition. We're going to take our problems, we're going to transpose them into log form. Okay, into log form. Okay, now here's the key. You got to watch. Everybody's got to watch. The base, that's my 10. So whatever number's here, when I rewrite as a log, watch, let me do this carefully. You write log, you write log, you write log. We're doing logarithms. So you have to write log. So we're going to change it from exponential form into log form. Start with log. Now, the base number is this number. So in this case, we're going to put a 10 right here. Okay, to transfer it, so whatever, this is the base, this is 10. So we'd go log of 10. So this number here, whatever number's here, goes down below as a subscript. It's the base of the logarithm, okay? And then of the answer, well, this is my answer, so I'd go parentheses. My answer in this case is 1,000, right? And then equals the exponent. So in this case, my exponent is my 3, okay? One more time. I want you to see what I just did. I transposed this exponential equation. I transpose it into a log equation. I put the log, put the base, which is this number, goes there. The answer, which is the 1,000, goes there, equals the exponent, which is 3. Okay? Now, base 10. We live in a base 10 world. And this is why we live in a base 10 world. A long time ago, we started counting on our hands. Way, way long time ago. Our entire math system is set up on base 10. Okay? So our calculators will do logarithms. So when you go to the calculator, I want you to see this. If you go to the calculator, clear, you've got a log button right here, okay? The logarithm in the calculator is already in base 10. It is always in base 10. It's called the common log, okay? Common log is base 10. So if I use my button, when I hit log, I want you to see this. There's no base right here. It's implied 10. Does that make sense? If the calculator is always base 10. Can we do other bases? Yes. But the calculator is always base 10. So there's an invisible 10 here. So if I go log 1,000, I get an answer of 3. Okay, so the calculator can do it. Now let's go ahead and figure out what we just did. We know that rewrite is 10 to some power equals 1,000, right? You know it's got to be 3, agree? You know it's got to be 3 because 10 to the third power is 1,000. The calculator just does it for us. Now sometimes we're not going to know. So on that one on the board, we're going to learn how to do that one later, but we don't know what it is, right? Okay, so now let's keep going with this. Let's look at example 2. Okay, and example 2's got solve log base 2. Our calculator doesn't do base 2. So we might have to use our brains. So in this case, we're going to change this one from log form to exponential form. So we're going to rechange this to exponential form. Please, everybody watch, please. Okay, this little number 2 is my base, right? So I want to go to exponential form. I want to put it as, that's my base. So to go to exponential form, I'm going to go 2. This 8 technically is the answer, so it's going to have to go over here. And this x, which is the exponent, okay? So what I did is I rewrote it as 2 to the x power equals 8. When you transpose it from, here's the base, that's the exponent, and that's the answer. I went 2 to the x power equals 8, okay? That's all I did, okay? So what is 2, what does x have to be? Everybody agree? 3? Because we know 2 times 2 times 2, so x equals 3. So what we found is the answer to log base 2 of 8. The answer to log base 2 of 8 is equal to 3. Now, if you're unfamiliar, if it's a little bit weird, you've never seen it before, okay? Let me keep going. We're going to get good at this, okay? Okay, let's look at example 3. So now it says solve. Well, let's change it to log form to solve it. Now I'm guessing x is about 2 point something. 2 point something because I know x squared is 100, x cubed is 1,000. I'm guessing 2.2. But we can get exactly what it is. So let's change it to log form. So we're going to change it to log form. We want to put it in log form. So we're going to go log of the base, and the base is 10, of the answer, which is my 321, is equal to the exponent. So I just changed this problem from exponential form into log form. So I took the 10 to the exponent, right? And I rewrite it in log form, log of the base 10, of the answer equals the x, okay? Now, if it's base 10, guess what? Our calculator can do it. This is log base 10. We can just use our calculator. Go, okay, I can do this. If I go log, hit my log button, okay, hit my log button. The base 10 is invisible. If it's calculator log, it's always base 10 of 321. I'm thinking 2.2, 2.5. Well, I was wrong. Okay, so the answer is about 2.5. Okay, now let's check this out. So if I really did go 10, I want you to see this. 10 to the power of that. I know my answer is going to be 321. Check it out. If I go 10 to that power, 321, what do you know? So what we're doing is solving for the exponent. We solved for the exponent by using logarithms, okay? We just rewrote it as log, that's my base 10 of the 321 equals the x. Okay, we just transpose it from exponential to log, okay? All right, now let's go down to example 4. Thumbs up so far? Okay, it just takes practice. This is going to take a day where I hope you do your homework because it just takes practice to get it to go from one form to the next. If you don't practice this, then you probably are going to be at a disadvantage come the next quiz, right? Okay, example 4. Rewrite log base 3 of x equals 4 into exponential form. So I'm going to go 3, that's my base, 3 to the 4th power equals x. I'm going to go with the base, 3 to the 4th power, so I'm just going to go 3 to the 4th power equals x, okay? So I'm transposing it, and I'm just using the rules up here. So I'm going to go, here's my base, to the exponent equals the answer, okay? And now we know what 3 to the 4th is. 3 times 3 is 9 times 3 is 27 times 3 is 81. You okay with that? So x is 81, okay? How am I doing? Okay, 5. Log base 4. It's base 4, so it's not on my calculator, but I can do this. So let's change it from log form into exponential form, okay? Exponential form. So I'm going to go, first of all, let's set it equal to x. I like to set it equal to x, so I got something, I can go this to this equals this, right? So I like to set it equal to x. So I'm going to go 4 to the x power equals 64. I'm going to go 4, that's the base, to the x power, so I'm going to go 4 to the x power equals 64. So I transposed it from log form, 4 to the x equals 64. Okay, now what is that? Well, 4 times 4 is 16 times 4 is 64, so x has got to be 3. See that? 4 times 4 is 16 times 4 is 64, so x has to equal 3. Okay? So far, so good? We just need to practice this. Today we need to practice moving it from one form to the other. Okay, so let's look at example 6. Set it equal to x. I already know the answer is 2, but we'll see why the answer is 2. We're going to go 36 to the x power. Oh, I was wrong. It's 1/2. I lied. 36 to the x power equals 6. Okay? So I went 36 to the x power equals 6. Okay? How's that look so far? Now, how can I make 36 into 6? Square root, right? So I know that the square root of 36 equals 6. But as an exponent, square root is the same thing as a 1/2 power. You guys remember that? Remember that? So x has obviously got to be 1/2. Because we know that it means 1/2 power means square root. We know the square root of 36 has to be 6. Did I explain that well enough? Okay, one more time. We know the square root of 36 is 6. And we know the square root is the same thing as a 1/2 power, okay? And if you didn't know that, make sure you write that down somewhere, that the square root of, if you have the x to the 1/2, that's the same thing as the square root of x, okay? If you need to write that down as a side note, right? 1/2 power means square root. You got a little 2 that's invisible here, and a little 1 that's invisible here that makes the 2 and the 1. They're both invisible, but we know square, right? Okay? Example 7. Log. Now this is a calculator log. We could do it on a calculator, but I don't want to. I want to do it on our brains. We could just go log 1, and guess what you're going to get is 0, but I want to show you why it's 0. Seriously, log, it's calculator log because there's no base. It's base 10. It's calculator log, right? So let's check it out. So let's set it equal to x. What's the invisible base here? 10. So if I go log base 10 of 1 equals x, right? Okay. Then I can transpose it to exponential form. I'll go 10 to the x power equals 1, okay? 10 to the x power equals 1. But hopefully we know that anything to the 0 power is always going to be 1. Do you guys agree with that? X has to equal 1. Now, or 0. Now, let's say you don't believe me. The calculator will actually do it. You can go log of 1, right? Just try it. If I just went log of 1, boom. Boom. There it is. Scoot over so you can see it. Okay, so the base 10 is invisible. When I use my calculator, it's always base 10. Any other base, we're going to have to find a different way to do it. Some of these fancy, like, so your calculator will do other bases, but we're not going to talk about your calculator, okay? Okay, example 8. Log of 0 is impossible, but I'm going to show you why. This one's going to be no solution. But I'm going to show you why it's no solution. First of all, let me show you that the calculator agrees with me, okay? Okay, if I went log of 0, yep, doesn't like it, does it? Error, domain, it doesn't like it at all. Okay, now why can't we do log of 0? Let's check it out. So if I went log, and again, what's the base? 10, right? It's an invisible. 10 of 0. And I'm going to set it equal to x so I can solve it, okay? So then I'm going to go, okay, 10 to the x power equals 0. Okay, so tell me, come on, let's think this through. You can't make this, because even if I use a negative number, it wouldn't work. If I use 0, we know 0 is going to be 1. If I use a negative number, it just makes it a fraction. It can be imaginary, right? Yeah, exactly. In fact, real quickly, let me do a little side work so you believe me. Okay. All right, you ready? 10 to the negative 1 is the same thing as 1/10. That's not 0, is it? It's not even negative, is it? 10 to the negative 2 is 1 over 10 squared, which is 1/100th. That's not 0. Nor is it negative, right? Even if I went 10 to the negative gazillion, it's going to be 1 over, which is a really, really small decimal, but it will never equal 0. And it's never going to be negative, is it? So what we know about logarithms is this. The domain of logs. The domain of logarithms is always x has to be greater than 0. You can never make it any less, okay? Are you ready to turn the page?
No.
Okay, I'll wait for you. Didn't I do evens or something like that? Oh, I'll change that. Don't worry, I'll change that, okay? Okay, turn the page. No, that's too many. Odds be okay. So, number 9, let's graph this first. I know that, so we can do this pretty quickly. Do this in our head. 2 to the 0 power, you guys. What is 2 to the 0 power? Thank you. What is 2 to the 0 power? 1. So, we'd have a point at 1. What is 2 to the 1 power? 2. What is 2 to the 3rd power? 8. It is 8 is right. Oh, I forgot 2 to the 2. My bad. 4. 1, 2, 3, 4. Thank you, though. 2 to the third power is 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to run out of room because 2 to the fourth power is 16, right? Way up here, okay? What is 2 to the negative 1 power? It is 1/2. Nice job, Claire. What is 2 to the negative 2 power? 1/4. 2 to the negative 3 power is 1/8. And I'll probably stop there because I'm going to run out of room, right? So yesterday we graphed this. No, I'm sorry, 2 days ago we graphed this, didn't we, right?
Yes.
And we talked about this silly thing called an asymptote. Say it carefully. Say it carefully. Don't say it in a naughty way, okay? Okay. So we have a horizontal asymptote at y equals 0, right? And what the asymptote tells us, girls, remember you were not going to talk when I was teaching. Thanks, girls. So what the asymptote taught us the other day was that it's going to get closer and closer to this line, but it never touches it because you can't get to 0. Half of a half of a half of a half will never get to 0, right? Half of a half of a half of a half of a half, you'll never get to 0. And that's why you have a horizontal asymptote. Now, let's look at its inverse. Okay, we talked about inverses yesterday, okay? So if we look at its inverse, we have all of these points. So this is a point at 0, 1. Its inverse would be at 1, 0. Okay? This point here is at the point 1, 2. Its inverse is going to be at 2, 1. Lane, what's up? Go ahead. I'm going to keep teaching, okay? This one is at 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 4. Its inverse is going to be 4, 2, right? This point's at 3, 8. Its inverse is going to be at 8, 3. 1, 2, 3, 4, 5, 6, 7, 8, 3, okay? Now, this point is at negative 1, 1/2. Its inverse is going to be at 1/2, negative 1. This point is at negative 2, 1/4. Its inverse would be at 1/4, negative 2. And I think you can see from here what it's going to look like. Okay? And instead of having a horizontal asymptote, this graph would have a vertical asymptote. Does that make sense? We'd have a vertical asymptote because this line, this pink line, will never touch the y-axis, right? So we would have what we call a vertical asymptote. Now what we found was a log graph. So the inverse of an exponential is a log. The equation to this one is going to be y equals log base 2 of x. That is the equation of its inverse. So an exponential function has an inverse. The inverse of an exponential function is the log function, right? Now, let's look at domain and range. Okay, so first, exponential. So let's look at the domain and range of the exponential. Okay, now first of all, this graph, okay? This graph. How wide is this graph? Pretty wide. As it's going up, is it still moving over? Will it always move over? Yeah, sure. So the domain of the exponential is simply going to be x equals all real numbers, okay? Right? And that makes sense to me because x can be anything. I can let x be anything I want in this equation, right? And not only that, but when I graph it, all x values appear. Even though they're going up, they're still scooting over, aren't they? The range, though, on an exponential...
We can't see it.
Oh, thanks, Katie. The range on the exponential starts at 0, but doesn't quite hit 0, but goes up from 0. So we'll say the range is going to be y is greater than 0, okay? So that's going to be the range of an exponential. It can never be 0, can't be negative, right? If we look at its inverse is the log. It's a log of x function, okay? Its domain, let's see what its domain is. So if I look at the exponential, here's the exponential, but if I look at the log, which is in pink, it never touches at 0, does it? So the x values are going to have to be from here over. The x values are from here over, or x is greater than 0. And if I look at the range of the logs, it goes forever down, and even though it's leveling out, it will always go up, won't it? It's always going to gradually go up. So if you reach for your range, the range of the logarithm is all real numbers. So the range is y equals all real numbers. Okay? And that's all I have. So, before I conclude though, one more time. The domain of the function becomes the range of its inverse, right? We talked about that yesterday. And the range of the function becomes the domain of its inverse, because for inverses, x become y, which means the domain becomes the range. Right, Lane? Lane knows that. Okay, so let's change this to odd. We'll go 1 to 29 odd. And we'll stop the recording.